Hello viewers, in today's lecture we are going to take up this topic which is a solution of quadratic equations with real coefficients in the complex number system. Viewers, in our earlier classes we have discussed about how to solve a quadratic equation of this type, right? Ax square plus bx plus c is equal to 0. Here a, b and c are real numbers and a is not equal to 0, right? So what is a quadratic equation? A quadratic equation is an equation of the form ax square plus bx plus c equal to 0. Here the degree is 2, right? And the coefficient of x square is not equal to 0, and a, b, c, these numbers belongs to the set of real numbers. Clear? So in our earlier classes we have seen that the discriminant of this quadratic equation is given by d is equal to b square minus 4ac, right? And the quadratic formula to solve this equation is given by x is equal to minus b plus minus square root of d divided by 2a, right? So here the quadratic equation has two roots, right? Either we can say two roots or two solutions. So let us denote the roots by the letters alpha and beta, right? So alpha can be given by minus b plus square root of d divided by 2a, and beta can be given by minus b minus square root of d divided by 2a. So viewers, this is a brief introduction of quadratic equations which we already know. Now in our this topic we have to solve a quadratic equation in the complex number system, right? So let us take an example what is meant by solving a quadratic equation in the complex number system. Now viewers, here I have written two equations. This is x square minus 2 equal to 0, and here we have x square plus 2 equal to 0. Both these equations are quadratic equations. Now let us solve these two equations and let us see the nature of roots. So here we have x square is equal to 2, so we have simply plus minus square root of 2, and we see that plus square root 2 and minus of square root 2, both these numbers belong to the set of real numbers. So we can say that this equation or this quadratic equation is solvable in the set of real numbers. It means the roots of this equation belongs to the set of real numbers. Now let us solve this quadratic equation. So here if I write x square is equal to minus 2, it means we have to now take the square root of a negative number, right? And we have already seen in our introduction of complex numbers that such an equation does not have its roots in the set of real numbers. So viewers, what we do here, we'll write x is equal to square root of minus 2, right? And we know that the iota I is equal to minus square root of minus 1, or I square is equal to minus 1. So therefore x can be written as I root 2, and here we will write plus minus. Okay, so therefore the two roots of this quadratic equation is I root 2 and minus I root 2. And viewers, these two are complex numbers, and they belong to the set of complex number system. So such quadratic equations whose roots does not lie in the set of real numbers are said to lie in the set of complex numbers. Clear? So let us now take some more problems. Now viewers, here we have this equation. So if we compare this equation with this equation, we get a1, b1 and c is equal to 1. So the discriminant is b square minus 4ac. So we see that this is 1 square minus 4 times 1 times 1, that is 1 minus 4, that is minus 3. And we know that if the discriminant is less than 0, then the quadratic equation has its roots in the complex number system. So we have complex roots here, right? Complex roots, or in other words, we can say that this quadratic equation has the discriminant less than 0. So therefore the roots of this quadratic equation are imaginary. So we can say imaginary roots or complex roots. Now let us find the roots. So we have x is equal to minus b plus minus square root of d divided by 2a. Now if we substitute these values here, we get minus 1 plus minus square root of minus 3 divided by 2 times 1. And we can write it as minus 1 plus minus, this is I square root 3 divided by 2. So viewers, always remember that minus of a is equal to I times square root of a, where a is some real number, right? So here we have the two roots are given by first one is minus 1 plus I root 3 divided by 2, taking the positive sign, and the other root is minus 1 minus I root 3 divided by 2, right? Now viewers, let us take this problem. Here we have 9x square plus 10x plus 3 equal to 0. So if we compare this equation with this standard quadratic equation, we have a is equal to 9 and b is 10 and c is 3, right? Now the discriminant d is b square minus 4ac, and this can be calculated as 10 square minus 4 into 9 into 3. So this is 100, and this is 9 3s are 27, 4s are 108, right? So this is minus 8, and this is less than 0. So the discriminant is less than 0, so we declare that this quadratic equation has as complex roots, right? Complex roots. Okay, now we will apply this formula here to find the roots of this equation. So here we have x. Now for b we have minus 10, and here we have plus minus square root of minus 8 divided by 2 times of 9, right? Now this can be written as minus 10 plus minus, and this is I root 8, right, divided by 18. Clear? Now if we take the square root of 8 is equal to 2 root 2, so if we substitute it here, we have minus 10 plus minus I times 2 root 2 divided by 18. Clear? Now dividing, taking 2 common from numerator, we have 2, and here we have minus 5, we have plus minus I root 2 divided by 18, and these 2 get cancelled here. 2 9s are 18, so we have minus 5 plus minus I square root of 2 or iota square root of 2 divided by 9. So the 2 roots are given by minus 5. The first root is minus 5 plus, taking the positive sign, so we have I or iota times square root of 2 divided by 9. This is the first root, and the second one is taking the negative sign here, so we have minus 5 minus I root 2 divided by 9. Clear? So these are the 2 complex roots of this quadratic equation. Now viewers, let us take this problem. So if we compare this equation with this equation, so we have a is 2, b is minus square root of 3, and c is equal to 1, right? So the discriminant is b square minus 4ac. So here we have minus of square root of 3 square minus 4 times 2 times 1. So minus square is plus, so root 3 square is 3, and we have here 8, so we have minus 5, and this is less than 0. So therefore this quadratic equation has complex roots or imaginary roots. So the roots are given by the quadratic formula, that is minus b plus minus square root of t divided by 2a. So we substitute the values here. We have minus of minus root 3 plus minus square root of minus 5 divided by 2 times 2. Now this can be written as this is minus minus plus, so we have square root of 3 plus minus iota square root of 5 and divided by 4, right? So the roots are square root of 3 taking the positive sign, so we have square root of 3 plus I root 5 divided by 4. This is the first root, and the second root is square root of 3 minus I square root of 5 divided by 4, right? So this is the solution of the given quadratic equation. Now viewers, I am taking one more important quadratic equation, and the special thing about this quadratic equation is that the value of b here is 8i or 8 iota, and this coefficient 8 iota or b belongs to the set of complex number. And here we have a is equal to 3 and c is equal to 3. So the special thing about this quadratic equation is that all the three coefficients, that is a, b, c, they are not all real numbers. Only a and c are real numbers, right? And b is a complex number. But the method of solving this quadratic equation is same what we are discussing right now. So let us solve this quadratic equation. So let us first find the discriminant, that is b square minus 4ac. So here we have 8i or 8 iota. I am calling this iota as I, right? So this is 8i square minus 4 times 3 times 3. So here's this is 8 square 64 iota square, and this is 36, right? And we know that iota square is minus 1, so we have minus 64 minus 36, that is minus 100, which is less than 0. So therefore d is less than 0. This implies that this quadratic equation has complex roots, right? Now let us find the complex roots. So the roots are given by the quadratic formula, and if we substitute the value of a, b and c here, so we get minus of 8i or 8 iota, and then we have plus minus here. This is a square root of minus 100, right? And this is divided by 2 times of 3. Now this can be written as minus 8i or 8 iota minus 8 iota plus minus, and we know that the square root of minus 1 is iota, and square root of 100 is 10. So this is 10 iota. So this is divided by 6. And if we take the plus sign, that is positive sign, so the first root is minus 8i plus 10i divided by 6, and the second root is minus 8i minus 10i divided by 6. Now this is x is equal to 10i minus 8i is 2i divided by 6, and here we have minus 8i and minus 10i, that is minus 18i. 18 minus 18 iota divided by 6, right? Okay, now the values of x are, this is 2 3s are, so we have iota divided by 3, and here we have 6 3s are 18, so we have minus 3 times of iota. So these two are the complex roots of this quadratic equation, right?